Hello students, welcome to Sankalp Learning. I am Aishwarya and we are having the third session of electrochemistry. So now we are going to start with Nernst equation. So what is Nernst equation? It relates the mathematically the electrode potentials. Okay. So see, till now we saw the electrode potentials in standard forms. Standard electrode potential nodidvi. Taking 1 molar concentration, 1 bar pressure, temperature to be 298 Kelvin, then 1 bar pressure togondidvi. And what was the concentration? Tell me. The concentration was 1 molar. The concentration was 1 molar. So till now we saw electrode potential in the standard form, I mean to say at 1 molar concentration. Now, what if I want electrode potentials at different concentrations? Very concentrations alli nanu electrode potential check madbekitandre who will help me out? So here is the rescue, that is Nernst equation. So Nernst equation is what? You can remove the electrode potential at any concentration with the help of this Nernst equation. So if I say I'm going to denote standard electrode potential as E naught. We know this in our previous classes we have seen. Then what will be my electrode potential? Electrode potential will be E. Therefore, I can write, so E naught is what? E naught is electrode potential, reduction potential. And so reduction potential andru one, electrode potential andru one, because by convention itself, we know that electrode potential andaga we are talking about standard electrode potential. Fine. So E naught is the reduction potential, standard reduction potential at 1 molar concentration. Now, I want to find the electrode potential of the electrode at any concentration. At any concentration measure madbekidaga, how will I do it? The equation goes something like this. The electrode potential, the reduction electrode potential, Mn plus bar Mn. This is gaining electrons to become M. So therefore it is reduction potential. That is equal to the standard reduction potential, Mn plus bar M. So standard reduction potential minus RT bar NF natural log concentration of M by concentration of Mn plus, that is concentration of the metal in solid form to the concentration of its ion. Electrode in solid form reaction. You can see here Mn plus electrons, it will gain n number of electrons to form N. So this is in solid form, concentration of M by concentration of Mn plus ions. Fine. So let us see what are the terms here. Terms. So this is electrode potential, reduction potential. We know that. This is standard reduction potential. That is also known. What is R? R is gas constant. R is gas constant. And what is its value? Its value is 8.314 joules per Kelvin per mole. Yes, 8.314 joules per Kelvin per mole. What is T? T is temperature, which is measured in Kelvin. Okay. Then what is N? N is the number of electrons which are involved. Number of electrons involved. So reduction gain ಆಗ್ತಿದೆ. How many electrons are being gained? ಎಷ್ಟು electrons ತಗೊಳಕತ್ತೈತಿ? N number of electrons ಅಂತೀವಿ. N number. So N is the number of electrons gained during the reaction. Then what is this F? F is called Faraday's constant. Faraday's constant. And its value is, I'll write here, 96. Please remember this value and I'll tell you how this value came also. When we'll be discussing further parts of the concepts, I'll let you know how that value came. So Faraday's constant is 96487 coulomb mole inverse. Coulomb per mole. This is the value of Faraday's constant. Approximately ಕೆಲವೊಮ್ಮೆ ನಾವು ಏನು ತಗೋತೀವಿ to solve numerical solve ಮಾಡೋದು easy ಆಗಲಿ ಅಂತ ಹೇಳಿ we take it as 96,500 coulombs. Okay, fine. So next is what? Concentration of M. Bracket ಒಳಗೆ ಬರೆದು ಬಿಟ್ಟು concentration of M ಅಂದಾಗ what does that mean? It means the concentration of solid. Concentration of solid. And by convention, concentration of solid is always taken as 1. So equationally, in this equation, I can write concentration of solid as 1. Okay, fine. Then what is Mn plus? It is the concentration of the ions. Mn plus ions. How much concentration? Bracket, square bracket. What So when we apply Nernst equation to Daniell cell, what will happen? Let us see. So Daniell cell in here is Zn, which is in solid form, plus Cu plus 2, which is in solution, gives Zn plus 2. Zn will lose electrons and come into the solution, plus Cu solid. Is this the Daniell cell? Fine. If you apply Nernst equation, what is Nernst equation now? Nernst equation, I'll apply it for Daniell cell. Bar m. This is my Nernst equation. I'll write general form. Mn plus bar m minus RT by NF natural log 1 by concentration of Mn plus. Correct. This is my Nernst equation. Is that right? Okay. Idanna now Daniell cell apply madidaga. What do I get? So tell me what is there at cathode. At cathode we have E Cu plus 2 bar Cu. So I'll write it as E naught Cu plus 2 bar Cu minus RT by how many electrons, students? Cu plus 2 ididu Cu agakatati andmele. So plus 2 andre it will take 2 electrons and then it will become Cu. Therefore I can write 2F. Yes. So natural logs 1 by concentration edurdu 1 by concentration of Cu plus 2. Similarly at cathode, at anode hatra yenagakatತಿ ಹೇಳಿ. So at anode Zn plus 2 bar Zn electrode potential is equal to standard reduction potential of Zn plus 2 bar Zn minus RT. How many electrons again? 2 electrons into F. natural logarithm 1 by Zn plus 2. 1 by Zn plus 2. Correct? So if I want to determine the entire EMF of the cell, if I want to determine the entire EMF of the cell now, how I'll determine entire EMF? What is the formula for EMF? What we have studied? Fat, you have to give me the answer. So E cell is equal to what? E cell is equal to E cathode minus E anode. ಅಥವಾ ನಾನು ಏನ್ ಅನ್ಬೋದು ಈ ಕ್ಯಾಥೋಡ್ ಅಲ್ಲಿ ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಶಿಯಲ್ ಆಫ್ ಕ್ಯಾಥೋಡ್ minus reduction potential of anode. Is that right? Fine. Let us see. So reduction potential at cathode only Cu plus 2 bar Cu minus E Cu, sorry, Zn plus 2 bar Zn. Is that right? Now you substitute the values from here. Cu plus 2 bar Cu ಏನಿದೆ? So I'll substitute it. I'll write here. So I'll write it as E naught Cu plus 2 bar Cu minus RT by 2F natural logarithm 1 by concentration of Cu plus 2 minus E naught Zn plus 2 bar Zn minus RT by 2F to the natural logarithm 1 by concentration of Zn plus 2. Is that right? Understood up to here? Now further you solve. So how will we solve it? E cell is equal to E naught Cu plus 2 bar Cu minus E naught Zn plus 2 bar Zn. I'll take it in at one side. So I'll take this one side. Okay. Minus RT by 2F is common. So I can write this as natural logarithm 1 by concentration of Cu plus 2 minus natural logarithm 1 by concentration of Zn plus 2. Simple calculation, simplifications I'm doing, substitution and simplification. So I will write E cell is equal to, what is this? E naught Cu plus 2 bar Cu minus E naught Zn plus 2 bar Zn. What is this? This is nothing but standard EMF. Yes, so I'll write E naught cell, correct? Minus RT by 2F to the natural log. When you solve this out, you will get Zn plus 2 bar Zn plus 2 bar Cu plus 2. So this is the Nernst equation. This is the Nernst equation for Daniell cell. So in general, if I say, if I'm having A moles of A and B moles of B reacting to give C moles of C plus D moles of D. If this is my reaction, then what will be Nernst equation? What will be Nernst equation? Tell me. Nernst equation will be E cell is equal to E naught cell, standard cell potential, minus RT by NF, number of electrons into Faraday constant, natural log, concentration of C raised to C, coefficient bekala, concentration of D raised to D, to concentration of A raised to A and concentration of B raised to B. Up to this it is clear. What I'm trying to say here? Yeah, fine. So what are the applications of this Nernst equation? What are the applications? Applications use martivappa. Applications of Nernst equation. Teacher, just now you said when we want to find the molar, when we want to find the electrode potentials at any concentrations, we make use of Nernst equation. Fine. What are the other applications? The first application of this Nernst equation, where we use this Nernst equation is, I'll write here, you can see, to find the EMF of a cell. E cell to find the EMF of a cell at given concentration. At given concentration of species. What the concentration EMF of the cell can be found out. The second application is to find equilibrium constant. To find equilibrium constant for a reaction. Reaction, the equilibrium constant we'll see one by one all these applications. Then to find Gibbs energy of a reaction. Then let us see one by one. Okay. So consider an example now. So consider an example where let me say represent a cell in which following reaction takes place. So you have to represent a cell. I'll write the reaction, you represent the cell, okay? Mg solid plus 2Ag plus, this is given, okay? 0.0001 molar concentration. Here it is Mg plus 2, which is at 0.130 molar concentration plus 2Ag. Calculate its E cell if calculate E cell if EV is equal to 3.17 volts. So EV andre ಏನು? What is EV? New term ಅಲ್ಲ, ಏನಪ್ಪ ಕಲ್ತೆ ಇಲ್ಲಲ್ಲ ನಾವು, ಹೌದೇನಿಲ್ಲ? So EV is basically E naught cell. EV na ಹೆಂಗ್ ಬರಿತೀವಿ? It is basically E naught cell. Okay. So standard reduction potential of the cell. Fine. So let us see how we'll do it one by one. Now what Nernst equation says? Nernst equation. So let me say I'm calculating here. Nernst equation says, what equation ಹೇಳಿ ನೋಡೋಣ. E cell is equal to E naught cell minus RT by 2F. Why 2F? Tell me. Because see here, Mg it is becoming 2 plus 2. ಅಂದ್ರೆ ಏನಾಗಕತ್ತೈತಿ, 2 electrons ನ ಕಳ್ಕೊಂಡ್ಬಿಟ್ಟು plus 2 ಆಗಕತ್ತೈತಿ. Ag plus is becoming Ag. Ag, one Ag ion, it will take 1 electron. Here we have 2 Ag ions. So they take 2 electrons. So number of electrons is what? 2. Okay. To the natural log concentration of Mg plus 2 to the concentration of Ag plus 2. The whole square. Because there is coefficient for Ag plus. What is the coefficient of Ag? The coefficient of Ag is 2. So Ag plus the whole square. This is my Nernst equation for this above equation. Is that right? So illi I have not taken Mg and I have not taken Ag. Why tell me? Because concentration of solids is what? It is 1. Yes, therefore I have not taken, I have taken only the ions. See, to simplify this, okay, to simplify this, I'll write, what is E naught cell given? E naught cell given is 3.17. Fine. So 3.17 minus this R, T and F and the natural logarithm. They are all constants. Howda? Constants idava. So all these values substitute ಮಾಡಿ, ನೀವು simplify ಮಾಡಿ, if you try to see, ಎಷ್ಟು ಬರುತ್ತಪ್ಪ ಅದ್ value? The value comes out to be 0.059. 0.059. So divided by, ಎಷ್ಟು value ಇದೆ? Here I have 2. So ln ತಗದ್ಬಿಟ್ಟು, it becomes logarithm. Okay. So here, what is, how much value is given? How much value is given for concentration of Mg plus 2? Tell me how much value is given. Here we have the value. So value is 0.130 divided by, what is the concentration of Ag plus? The concentration value is 0.0001, the whole square. Is that right? So when you solve this out, you'll get 3.17 minus ಇದನ್ನೆಲ್ಲ solve ಮಾಡಿದಾಗ you will get, I'll not sit doing that part of calculation because it is known to you all, ನಿಮಗೆ ಮಾಡಕ್ ಬರುತ್ತೆ. So I'll not waste time in that. So solve this out, you'll get 2.96 volts. So we can find, ಇದರಿಂದ ನಮಗೆ ಏನು ಗೊತ್ತಾಗುತ್ತಪ್ಪ ಅಂತಂದ್ರೆ, we can actually find the EMF of a cell at a given concentrations. Concentrations ಕೊಟ್ಟಿದಾರ, you are calculating the EMF. So this is what, this is the value of E cell. EMF of a cell under cell potential under, we can find it. Is that clear? So this is the first application what we understood. Now coming to the second application, let us see. Now what we have to find here is, okay, so what we have to find here is, my question is how to find equilibrium constant. How to find equilibrium constant using Nernst equation. Using Nernst equation. Nernst equation use ಮಾಡ್ಬಿಟ್ಟು equilibrium constant ಹೆಂಗ್ ಕಂಡುಹಿಡಿಯೋದು? Now Daniel cell representation ನಿಮಗೆ ಗೊತ್ತು, Zn plus Cu plus 2 gives Zn plus 2 plus Cu. I'll not write it again and again. Okay. So the reaction is proceeding in forward direction. So reaction forward direction ಒಳಗೆ ಆಗಕತ್ತೈತೆ ಅಂದ್ರೆ ಅದರ ಅರ್ಥ ಏನು? Concentration of Zn plus 2 is increasing. and the C concentration of Cu plus 2 is decreasing. Can I say that? Concentration of Zn plus 2 is increasing. At the same time, concentration of Cu plus 2 is decreasing. Is that right? So it reaches a stage where when this reaction is proceeding with time, along with time, it reaches a stage where the voltmeter reading comes out to be 0. And this is the state where equilibrium is attained. There is the equilibrium constant. So I'll not go much in detail. Equilibrium andre enu, equilibrium constant andre enu. You know to represent equilibrium constant, right? Kc. So now at equilibrium, voltmeter reading ಎಷ್ಟು ಬಂತು? So now at equilibrium, let me write, at equilibrium, what is the voltmeter readings I said? 0. So I'll write E cell is equal to what? It is equal to 0. Yes, please try to remember what we have studied. So in a Daniell cell, I will represent it as at equilibrium. I will use this sign Zn plus 2 plus Cu. Okay. So what will be my E cell? E cell will be equal to, according to Nernst equation, E naught cell minus RT by NF natural log Zn plus 2 bar Cu plus 2. Right? Yes. And what is the equilibrium constant here? Tell me. Equilibrium constant Kc is nothing but what? Zn plus 2 bar Cu plus 2. This is I have studied in equilibrium. Kc andre enu equilibrium constant. So as we said, E cell is what? At equilibrium it is 0. So that is equal to E naught cell minus idella value substitute madana. So I'll get value natural log will remove and 2.303 RT by NF log. Tell me now, concentration of Zn plus 2 bar concentration of Cu plus 2. What it is? It is Kc. Log Kc. Yes. So this particular part is all constant. Idella constant howda. And what is the value we have seen? So I'll substitute it here. So I'll write E naught cell. This minus gets cancelled. Therefore, E naught cell is equal to 0.059 bar N log Kc. Yes. So specifically, if we talk about a Daniell cell, E naught cell has a fixed value. E naught cell, the value fixed again here, we have already found it. What is that fixed value? It is 1.1 volt. So yeah, what is N for Daniell cell? It is 2. So let us substitute all those values. So 0.059 by 2 log Kc. Solve it out. I'll solve it here. 1.1 into 2 by 0.059 is equal to log Kc. Idanna solve madi, you will get the answer. Log Kc is equal to 37.288. You will get this answer. Yes. Again, I'm saying I'll not go into deep calculations. Calculation part, you're going to do it on yourself. So the second one, finding the equilibrium constant of a reaction, is also done. Is that right? Now the third part is to determine, using Gibbs free energy, using Nernst equation, we are going to determine Gibbs free energy. Okay. Class 11, thermodynamics. Is that right? So thermodynamics only we have studied something called Gibbs-Helmholtz equation. Nenpidena? Gibbs-Helmholtz equation. What was this equation? Tell me. Bada deep hogod beda. Let us see the equation. Delta G is equal to delta H minus T delta S. A fantastic, a super duper equation. Yes. So delta G is equal to delta H minus T delta S. Let us not go in detail of this particular equation. But what we understood from this equation, tell me. This equation linda namaga ಏನು clear ಆಗುತ್ತೆ ಹೇಳಿ? If delta G is greater than 0, positive value ittappa antandre, then the reaction is non-spontaneous. Correct? These were the solutions for this equation anbodu. The reaction is non-spontaneous. If delta G is less than 0, negative, the reaction is spontaneous. Yes, we have studied it. And if delta G is equal to 0, what does that mean? What does that mean? Reaction is at equilibrium. Reaction is at equilibrium, correct? So here we are going to establish a relation between delta G and E cell potential ಮತ್ತು Gibbs free energy ನಡುವೆ we are going to establish the relation using what? Using Nernst equation. Fine. Okay. So what it says? Delta G, the relation is something like this, is equal to minus NF E cell. This is the equation. So we can understand one thing here. Looking at the equation Nodi, you will get to understand here what I want to convey here. Okay, please look at the equation. Delta G is equal to minus NF E cell. What conclusion we come from this equation is, if my delta G is positive, then what will be my E cell? E cell will be negative. See, delta G positive, E cell will be negative. If delta G is negative, negative cancels, E cell will be positive. So this is the conclusion. Now, when I talk in terms of standard form, I will write this equation as delta G naught is equal to minus NF E naught cell. Delta G naught is equal to minus NF E naught cell. If I want to write it in terms of equilibrium constant, the moment I talk about equilibrium means what? If I write Nernst equation and say it is at equilibrium, Nernst equation barbittu, what I'll say it is at equilibrium, then we know that E cell, what is E cell equal to? E cell is equal to 0. So if I make E cell 0 in Nernst equation, what will happen? E naught cell, ಇದು ನೋಡಿದೀವಿ ನಾವು equation already, NF by RT, the natural log, concentration terms ಬರ್ತಾವಿಲ್ಲಿ. And what is this concentration term? This concentration term is nothing but Kc. It is nothing but Kc. Okay, understood up to here? It is Kc. So delta G naught is equal to minus RT ln natural logarithm Kc. Now what is NF? NF is amount of charge passed through the cell. N into F. Here both the terms thrown biಡ್ತೀನಿ ನಾನು. It is amount of charge passed through the cell. Okay. And what is E? E is EMF of the R is what? R is my gas constant. What is T? T is the temperature. Is that right? Up to this it is clear? Yes? Fine. Okay. Now let us take an example. Let me take an example. Like the Nernst equation and EMF calculate ಮಾಡಿ for the following at 298 temperature. Okay. I'll write the equation, please see. SN solid bar cell representation ಹಾಕ್ಕೊಡ್ತೀನಿ 0.050 molar concentration, double bar H plus 0.020 molar concentration, bar H2 in gaseous form, it is at 1 bar atmosphere, comma, platinum inert electrode. Fine. ಇದಕ್ಕೆ ನೀವೇನ್ ಮಾಡಬೇಕು? You are going to write the Nernst equation. Okay. So write it. So equation paila barkodri. Sn plus H plus is there. Fine. So Sn ಏನ್ ಹಾಕ್ಲಿಕ್ಕತ್ತದ ಹೇಳ್ರಿ? Sn is becoming Sn plus 2 and H plus is becoming H2. Is that right? So H2 ಆಗ್ಬೇಕಪ್ಪ ಅಂತಂದ್ರೆ I want 2H plus here. Is that correct? Okay. So here Sn is becoming Sn plus 2. Loss of electrons, oxidation occurs at anode. H plus is becoming, this is my sheet. H plus is becoming reduction ಆಗ್ಲಿಕ್ಕತ್ತೈತಿ, gain of electrons, and reduction occurs at cathode, red cat. Is that right? Fine. Okay, let's write Nernst equation now. So E particular equation, Nernst equation. So E cell is equal to E naught cell minus 0.059 bar N log concentration of Sn plus 2 by concentration of H plus Raised to what? Raised to 2. Yeah, because 2 is my coefficient. Okay. And what is E naught cell? E naught cell is E naught cathode standard reduction potential, because they have said 298 Kelvin also, minus E naught anode. Okay, E naught anode. So cathode ಏನಿದೆ ಹೇಳ್ರಿ cathode. So I'll write reduction potential E naught H plus bar H2 minus E naught anode. What is anode? Sn plus 2 bar Sn. Okay, H plus bar H2, E naught H2. The standard reduction potential of She is always 0 minus. So if you see from the electrochemical series, the value for Sn plus 2 bar Sn, E naught reduction potential value is minus 0.14. Okay, therefore what will be E naught cell? E naught cell will be minus of minus a naitu plus 0.14 volts. So E naught cell siktu. Fine. So now let us calculate E cell. So I'll calculate E cell. What is the value of N? Tell me. N is there. Sn is becoming plus 2. So there is 2. So N is 2. What is the concentration of Sn plus 2? What is that? 0.050 molar concentration. What is the concentration of H plus? It is given as 0.020 molar concentration. Let us calculate. So E cell is equal to E naught cell 0.14 minus 0.059 bar 2 natural log. Lan illa illi. Yakandre I have taken the value and calculated. I have got a constant here 0.059. So log of Sn plus 2 concentration is to 0.050 bar 0.020 the whole square. Is that right? Solve this entire thing. You have to get the answer 0.078 volts. 0.078 volts. So this is how we calculate we can represent the Nernst, we can represent the cell, write it in the form of Nernst equation. Then we can calculate E naught of the cell. We have to calculate E naught standard reduction potential, and later you can calculate the E cell. You can calculate E cell. Let me take one more example. One example madbidana. Calculate standard cell potential. E naught cell has to be calculated. I'm not writing the entire question here. Of a galvanic cell in which following reaction takes place. So reaction or kottidara, you have to do the calculation. So 2Cr chromium solid plus 3Cd plus 2 in aqueous solution gives 2Cr plus 3 aqueous plus 3Cd. Okay. Calculate delta G, and all these things have to be calculated. This will be calculated one by one, because namaga applications of Nernst equation we have seen what all how these are related to one another. So firstly, look at the reaction and see which is the oxidation part and reduction part. That is not difficult, I feel, because illi varaku baalashtu examples tondidi. Cr is becoming plus 3. So plus 3 aglikadadandre enu loss of electrons. Loss of electrons is oxidation. Oxidation means it is occurring at anode. Okay, fine. Look, Cd plus 2, it is becoming what? Cd plus 2 is becoming Cd. Gain of electrons means reduction, and that is happening at cathode. Fine. Okay, so now I'll write Cr, it is losing electrons and becoming Cr plus